Hey guys, welcome to Algebra 2, Lesson 1A3, Simplifying Radicals. So I admit today's not going to be the most exciting lesson, but is one of those building blocks that's critical for your success in Algebra 2. So let's take a look over here on the left, a couple properties of radicals that we use all the time. The first one involves multiplication, all right, and this works both ways. So if you're multiplying two radicals independently, the result is the product of the square root of their product. And what I mean by that is if I have square root 2 times square root 3, that result gives me square root 6. Now the same thing works for division. And we don't use this as much, but it's also very helpful. So if I have the square root of, let's say, 6 divided by 2. That's equal to the square root of 6 divided by the square root of 2, which is just the square root of 3. A little vocab over here on the right. If I have c square root x, c is the coefficient, and x is called the radicand. So that is what's underneath the square root. Now what we want to do when we simplify these radicals is we want to break it up into two radicals. One of them is a perfect square and the other one is a non-perfect square. So numbers that are perfect squares, I'm just going to jot these down quickly. I'll review 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 225. I skipped 196, that's 14 squared. But we need to know all of those. Now when it comes to variables, we'll do variables in a minute. Let's just talk about numbers here. So the first example, square root 32. The largest perfect square that goes into that is 16. So I will break this up into two radicals, square root 16 times square root 2, because 16 times 2 is 32. Now the perfect square, we simplify. You need to know that the square root of 16 is equal to 4. So that comes out of the radical and it just becomes a 4. That means your simplified answer now is 4 square root 2. The next one, negative square root of 100. Now, I'm not going to do this necessarily the most efficient way, and the reason for that is 800 is a very large number. So the first thing I think of when I see square root of 800 is 100. So let's take a look at what I get here. Bring the negative along. I have square root of 100 times square root 8. Now, I know the square root of 100 is 10. So if I simplify that, I get negative 10 square root 8. But because this number was so large, there's a chance that this is not the largest perfect square that goes in. So now let's take a look at this. Oh, square root 8. I know that's the same thing as 4 times 2. So let's break this up one more time. Negative 10, square root 4, square root 2. And now this just becomes a 2. So I'm left with negative 10 times 2 square root 2. So that'd be negative 20 square root 2. 4 square root 54. 54 is pretty easy to work with. 9 goes in there. And I've got this 4 out in front. That's not part of a radical, so that just comes along. 4 square root 9 times square root 6. And the square root of 9 is just 3. So I end up with 4 times 3, which is 12, square root 6. 2 square root 63, again, 9 goes into 63, so let's break this up. 2 square root 9 times square root 7. And the square root of 9 is just 3, so that comes out. So now we have 2 times 3 times square root 7. So 2 times 3 is 6. That just gives me 6 square root 7. Number 5, we've got a fraction in front. Just bring that along. 2 square root 3. Perfect square that goes into 27. Again, we see 9. So 9 times 3. Then what happens is the square root of 9 is just 3. Now, a quick review of multiplying a fraction times a whole number. 2/3 times 3. Remember, 3 is the same as 3 over 1. And then that denominator and that numerator cancel. So that just gives me 2. So this right here is just going to give me a 2, which means my simplified answer is 2 square root 3. Now, number 6, this is where that property we talked about up above with division. notice I can divide these two. 80 divided by 8 is 10. The only thing we have to remember is that they're both underneath a radical. So the 5/2 comes out in front, but then square root 80 divided by square root 8 is just square root 10. And since I cannot simplify this at all, that's just my final answer. 5/2 square root 10. Now number 7, I cannot divide 27 by 4. So I can't use the same method I just did on number 6, which means I want to break this up into square root 27 over square root 4. Now you should recognize the square root of 4 is just 2. So my denominator is going to be 2. However, I cannot take the square root of 27, so that needs to be simplified. We're going to break that up, square root 9 times square root 3. The square root of 9 is just 3. So now my fraction, my simplified fraction, is 3 square root 3 in the numerator and a 2 in the denominator. Nothing else can be simplified there. Number 8, 1/2 square root 48. We'll just bring the 1/2 down. Square root 48, the largest perfect square that goes into that, is actually 16. All right, 16 times 3 is 48, and the square root of 16 is just 4. Now I have to take 1/2 times 4. That's pretty easy. That's just going to give me a 2. So now my final answer is 2 square root 3. Let's talk about variables. Neat thing about variables, when we take the square root of x squared, you probably know that one pretty easily, is just, that's wrong, it's just x. Sorry about that. The square root of x to the 4th is x squared. Now the reason it's x squared, we're not taking the square root of the exponent, we're dividing it by 2. So the square root of x to the 6th is x cubed. And the reason for that is, if you remember, x to the 6th is this. So if I take the square root, I want to know what times itself is x to the 6th. So that's why the square root of x to the 6th is x cubed. So basically a rule we can remember for that is the square root of x to some even exponent is always a perfect square. And what you do to get that exponent is you divide the original by 2. Now the issue with this is if it's odd, it's not a perfect square, but we can simplify it. The square root of x is just the square root of x. Can't do anything with that. However, the square root of x cubed we can think of as the square root of x squared times the square root of x. So the goal here is when we have an odd exponent, take out the largest even exponent we can, and then we always have a square root x left over. So now the square root of x squared is just x. That's outside of a radical. So this would give me x square root x. If I have x to the 5th, the largest even exponent is x to the 4th. So let's break that up. Square root x to the 4th times square root x. Square root of x to the 4th is just x squared. So my answer is x squared square root x. All right, so let's apply this to some more complicated radicals. I'm gonna go a little bit faster here, so if you have any questions, maybe rewind the video, watch it a little bit slower, or definitely utilize Math Clinic and or extra help. So, number 9, I'm going to first take a look at my number, 8. Let's break that up. Square root 4, square root 2. X to the 4th, yep, that's a perfect square, so I'll do this. Y to the 6th, yep, that's a perfect square, I'll do this. I'm writing down maybe a few more steps than you would need to, but I want to make sure I do this clearly. So square root 4 is 2. Square root of x to the 4th is x squared. Square root y to the 6th is y cubed. So everything in red is outside of the radical. What I haven't touched yet was this, and you can't do anything more with that. So outside the radical, I'll have 2, x squared, y cubed, and then underneath the radical, I have that square root 2. So let's just write that down. 2x squared y cubed square root 2. All right, number 10, square root 63. So we'll take a look at our number first, square root 63, break that up into square root 9 and square root 7. Now I have an odd exponent, x to the 7th, so I need to break that up into 2 radicals. One of them will be square root x to the 6th, the other one will be square root x and y squared. Notice I've put all of them underneath a radical right now. Then I evaluate all the perfect squares. So square root 9 is just a 3. That'll be outside the radical. Square root x to the 6 is just x cubed. Square root y squared is just y. So everything in red is outside of the radical. Anything I have not touched stays underneath. And we'll put those underneath as one radical. So now my final answer is 3 x cubed y square root 7x. Okay, and there's multiple orders. There's different ways you can approach these as long as you're coming up with this simplified answer. Some of you might prefer to take all of these and put them under one radical out in front and then take these and put them underneath. That's totally fine. It's a slightly different approach, a different order. But as long as you come up with that same result, you're doing it correctly. All right, so number 11 here, we've got yz outside of a radical. 27, that's 9 and 3. Y to the 5th, okay, so I have to take out the even y to the 4th, and then I have a y left over under a radical. And then z to the 8th is a perfect square. So now, square root of 9 is just 3. That's outside of a radical. Square root y to the 4th is y squared. Square root of z to the 8th is z to the 4th. So everything that's outside of a radical is this yz, a 3, a y squared, and a z to the 4th. So I have to multiply all of this stuff together, and that goes outside. All right, so let's see here. I have a 3. I have a y times a y squared, so that's going to give me y cubed. And then I have a z times a z to the 4th, so that's going to be z to the 5th. Now, underneath the radical, I have a 3 and a y, and that's it. So that would be 3y. Number 12, we've got 5x squared. That's not part of a radical, so that's outside. Oh, square root 16, that's nice. That's a perfect square. I'll take that in a second. X cubed is going to be square root x squared, square root x, square root y, and then square root z to the 4th because it's got an even exponent. So now what I can do with the square root of 16 is just 4, outside of a radical. The square root of x squared, just x. Can't do anything with the square root of x, can't do anything with the square root of a y. Square root of z to the 4th, z squared. So now let's take a look at what we have. This is outside of the radical, as is the 4 and x and a z squared. So we'll start with 5 times 4. That gives me 20. Then I have x squared times x. That's x cubed. And then I just have the z squared. Underneath the radical, I've got a square root of an x and a square root of a y, so that would just be an xy under the radical. Now notice your final answer here, we have one radical. So don't leave this as square root x times square root y. That's not simplified. We want to put this under one radical, like so. All right, 13. Let's take a look at some division here. One of the things that I'm going to look at, and hopefully I can do this, can I divide 24 by 8? Yep. X to the 5th divided by x. Yep, I can do that. Y cubed divided by y. I can do that as well. But don't forget, when you divide this stuff, it's still under a radical. The 5 is not, however, so that's going to be out front. Square root. 24 divided by 8 is 3. X to the 5th divided by x is x to the 4th. Y cubed divided by y is just y. So now this one's simple enough, I think, that we don't need to write this out. This is the only perfect square here, so that's going to be an x squared outside of the radical. So maybe I cross that out, and up here I write x squared. And that means I just have to multiply the 5 and that together, and then underneath I have a 3y. 5x squared, square root 3y. All right, 14. I love this one because I'm just going to divide everything. Now remember, I'm not simplifying, I'm just dividing, so I still have this square root as part of my answer. So square root, 12 divided by 6 is 2. X to the 6th divided by x cubed is x cubed. Now here, I have a variable to an odd exponent, so I can simplify that. Square root 2, square root x squared, square root x. The only thing that simplifies here is that, and that's just an x. That is all that's outside of the radical. then underneath I have a square root 2 and a square root x. So let's just jot that down, x square root 2x. All right, last couple. 15, 3 over 6. So this right here is our coefficient. 3 over 6 is the same thing as 1/2. Square root. 49, there's nothing to divide, so I'm going to keep it under the radical for now. Notice I have b cubed divided by b, so that'd give me a b squared. And then c to the 5th divided by c, that's c to the 4th. Now, it turns out here, everything is a perfect square, right? The square root of 49 is 7, the square root of b squared is b, the square root of c to the 4th is c squared. I'll just take a second to write that out. I'm sure a lot of you can probably do that in your head. That comes out. All of this stuff comes out. So now it's just a matter of multiplying 1/2 times 7, which I'm just going to write as 7/2. Obviously 3.5 if you like decimals, but fractions are good to work with. bc squared. And my last one. So again, I'll divide this out. Notice the 2 is on the top, 8 is on the bottom, so I'll have a 4 on the bottom, so that's the same thing as 1/2. H to the 7th divided by h is h to the 6th. Now, both of these are perfect squares. So square root of h to the 6th is h cubed. Oh. And square root of 4 is 2. And that's my final answer. All right, guys, that concludes day 3. I know this is a little bit dry, but like I said, it is one of the important building blocks that we use moving forward in Algebra 2. If you have any questions, don't be afraid to stop in and get help. Thanks a lot.